Every day, modern cities and large enterprises capture terabytes of video data. Thousands of cameras record continuous footage, resulting in a massive archive of completely unstructured visual information. This image shows a traditional security operator desk built to monitor raw, unindexed video feeds. In this setup, finding a specific incident requires human teams to manually scrub through days of timelines, a slow process highly prone to user fatigue and error. To eliminate this manual scrubbing, developers introduced natural language search. Instead of clicking through hours of tape, an operator types a simple sentence describing what they need to find. Look at this interface. An operator has entered a very specific test case query into the search field. Find a white car with a speed greater than 40. A traditional video management system instantly fails this request because it has no way to cross-reference pixels with text. Yet, modern AI platforms deliver exact video clips matching this description in under 100 milliseconds. Let's trace how that request is processed. An integrated large language model interprets the plain English prompt, standardizing synonyms and time ranges. It then translates the request into a structured JSON code filter, scanning a database for exact, multi-dimensional attributes like vehicle color and speed. This animated diagram demonstrates how that code travels. Instead of pushing data through a tangled web of API bridges or middleware, the query routes directly into a native event bus. This centralized hub connects disparate systems, like access control and video analytics, natively. API middleware often creates a 2 to 3 second alert lag. When dealing with dozens of cameras and high-priority incidents, that delay causes systems to display alerts after the visual evidence has already passed. A native event bus eliminates that lag. But this lightning-fast data routing exposes a technical reality. The query is searching a text database, not video files. To understand how that text is generated in the first place, we have to look back at the source. The process actually begins at the network edge, inside the individual cameras, long before anyone types a search query. These cameras continuously stabilize and pre-process live video as it is recorded. As the video rolls, embedded deep learning models like YOLO, an object detection algorithm, scan every frame. They isolate defined object classes, such as vehicles or people, and separate them from environmental background noise, like rain, reflections, or glare. The camera assigns metadata locally, logging attributes like a white four-wheeler speeding. This edge processing avoids sending massive raw footage, extracting only text tagged with a timestamp. Users simply filter this text database to retrieve the exact visual evidence. By shifting the heavy computation to the edge and indexing attributes in real time, passive surveillance is converted into a live, structured, and instantly searchable database. This transition from passive recording to active enforcement upgrades an organization's day-to-day operational intelligence. Teams can configure rules based on specific metadata combinations, filtering out noise and focusing strictly on defined risk behaviors. Urban planners use this structured data to analyze pedestrian movement and traffic infractions at complex intersections. In logistics, facility managers apply the same logic to track forklift speeds in shared work zones, automatically logging safety violations without watching hours of tape. This diagram illustrates another strict legal and security requirement: data sovereignty. Because the heavy processing happens on the camera, the raw video remains trapped safely on site in local servers. Only in a lightweight, text-based metadata pings upward to cloud management dashboards. This localized architecture ensures the system is resilient. If a facility experiences a total internet or WAN outage, the cameras continue to process analytics and buffer event logs locally, avoiding any blind spots in the security audit trail. Modern AI video surveillance relies on deep learning, edge computing, and natural language processing to extract structured text from raw pixels. The camera network operates as a live database, giving operators the exact information they need the moment they ask for it.